All right, we're doing lesson 24. It says understand comparing fractions, okay? We're not finding the equivalent fraction. Actually, we are not equivalent, but we're also comparing, okay? And also putting fractions in order. So this is session 1. So look at this one before we watch the video. It says draw this shape twice on your paper. So draw the shape twice on your paper. Draw this shape on your paper, on your composition book. Find a blank page. All right, then it says so we have to draw it twice, right? So let me draw it again over here. Something like this, you get the point. It says shade one shape to show 1/3. Okay, so look, I have 6 sections, right? Right? I need to find 1/3 of that. Okay, so look, pretend there isn't a line across. Okay, so let's do this. Pretend there isn't a line across like this. Okay, so 1/3 means this, right? Yes, that means 1/3. Okay, so if I put the line back, that means how many sections did I color in? 2. Okay, this is my third. If it says 2/3 though, how many sections would I have to color in? If 1/3 I colored in 2 of them, 2/3 I would have colored 4 of them. Even though there's 6 sections, technically it's 4/6, but 4/6 is equal to 2/3. Let me just show you. 1/3 right here, okay, is equal to 2/6. And here I have I have 2/3, which is equivalent to 4/6. Okay. All right. It says 523. It says, how do you compare fractions? Well, we just watched the video. How do you think? By using what? What were the circles called? Models, right? I could use, for example, a pie and divide into sections for each fraction and then compare them, which ones are greater, which ones are less. If it's greater than, less than, or equal to. Okay. So look at this. On page 523, it says shade the models at the right to show the fractions, okay? So here's one. It says 1/4 shaded. So how many squares am I going to shade? 1. Then it says shade 2/4. How many am I going to shade? 2 of them. All right, so far so good. That's what he told me to do. Now it says use the fractions 1/4 and 2/4 to complete the sentence. Blank is greater than blank. So out of those two fractions, which was greater? Yeah, so 2/4 is greater than 1/4 based on this model right here. All right, let's keep going. Okay, it says now use the number line on the right to compare. Well, again, which fraction is greater? 2/4 or 1/4? Which fraction is greater? 2/4, guys. Come on, watch. Okay, when comparing two fractions with the same denominator, how can the numerators tell you which fraction is greater? Well, look, I have 1/4, okay, and then I have 2/4. Okay. My denominators are the same. Okay. How do I know by using the numerators? How would I know which one's greater? Well, I need to figure out which of those numerators is greater than the other, right? Because my denominators are the same. I just have to look at my numerators and see which number is the biggest. What was that? Yeah, 2/4. So in this case though, like if I have them like this, if I have them like this, okay, if I have them like this, is 1/4 greater than 2/4? Okay, is 1/4 less than 2/4? Yes, so I'm going to do it this way. If I have it the other way, if I have it the other way like this, if I have it like this, 2/4 and then 1/4, what sign goes in the middle? Greater than, less than, or equal to? Greater than, because 2/4 is greater than, so it would be this way. Okay. Now look at this. Compare the shaded parts of the model. Can you use the models to show the sentence in problem 1b? So go back to 1b. Can I compare these? Can I say that 1/4 is less than 2/4? Why not? Okay, both squares have to be the same size like I did it on here, on this page. Are these two squares the same size? Yes. So I cannot compare these. Okay, they're not the same size. Okay. Exactly. This whole box right here is the size of this one. Okay. You can't say that if you have this size of a pizza and this is of a pizza, you have the same amount. No. This is like a mini pizza and this is like a medium or large. No. Okay. Look on page 224. It says which model on the right has more parts. So which one has more parts? Which one? Okay. B does. Which model has the smaller parts? Okay, wait. That doesn't make sense. So which model at the right has more parts? B does. But which model has the smaller sections? Smaller sections. B still does. Because A, its sections are a lot bigger. B still does. It says shade 1/3 of A. Okay, let's shade 1/3. Then it says shade 1/8 of model A. Got it. Right there. Use the fractions 1/3 and 1/8 to complete the sentence. Okay, let's do that. So right now, look at the model. Which one's greater? 1/3 or 1/8? Okay, this is 1/8. Look at the sizes of each section. So what's greater, 1/3 or 1/8? 1/3. Don't get confused with this. Oh, 8 is bigger than, no. Yes, individually, 8 is bigger than 3, but when it comes to a fraction where the numerators at the top are the same, okay, look at the models instead. All right, so 1/3 is greater than 1/8. That makes it true. Or like this, 1/3 is greater than 1/8. That's another way to write it. All right. It says label each part of each model at the right with the unit fraction. So the unit fraction is going to be the same thing on each square, okay? First of all, what's going to be my my denominator on letter C? 6, because there's 6 sections. And my unit fraction has 1 at the top. Okay? So what's my denominator for letter D? 4, because there are 4 sections. And what's my numerator? 1. A unit fraction has 1 as a numerator, and then how many sections do you have as your denominator? Okay? Okay. All right. Let's do part B. It says shade 3 parts of each model. Got it. So here's 3 right here. I'm going to shade. And here's 3 right here. I'm going to shade. So far, so good. Then it says, what fraction does each model show? Okie dokie. So what fraction does C show that I shaded in? What's 3/6? And then what's the fraction of letter D that I shaded in? 3/4. Yes, but are they the same? No. Which unit fraction from part A is greater? So is 1/6 greater or 1/4 greater? 1/4 is greater. Okay. Which fraction from part B is greater? So is 3/6 greater or 3/4 greater? What is it? 3/4. Look right here. See, 3/4 is further out. So 3/4 is greater. When comparing two fractions with the same numerator, okay, how can the denominators tell you which fraction is greater? Well, if my numerators or the numbers at the top are the same, my smaller denominator, that's the fraction that's greater, okay? I know it's kind of weird way of thinking, but that's what it is. But it's easier to draw a model instead, okay?